Okay, and then if we've got extra time on the day, the hint day, we can do more multiple choice. Okay, remember the multiple choice is always part of the hint, so and some of those will come on right from the multiple choice will be on the test. Okay, all right. So you tell me from there, what do you want me to talk about? Which one? Number 2. Okay, let me find. I lost the pen. Find the pen. Okay. All right, so we're looking at number 2 from the multiple choice here. That one? Nope. That was not number 2. There we go, that's closer. That one? Okay. This is one of AP's favorite. You can pretty much guarantee you're going to see something like this. If it's not this problem on the test, you'll see something like it on my test on Wednesday. Okay, so make sure you know how to do this one. So in order to see if the given function is continuous, or we actually have to find the k value that makes it continuous. Basically, it's like taking the limit of each side and plopping that number in. So really what we do is we take this guy and plop it in there, and then we set them equal to each other, okay? So I take the sine of 2 pi, and I set it equal to 2 pi plus k, right? So we need to go unit circle, right? What is the sine of 2 pi? 0 equals 2 pi plus k, so what's k equal to? Negative 2 pi. So it should have been answer choice A. Yeah, and mine is going to look, yours, I purposely don't have the computer mix the answer choices, okay? So yours, it should be the first answer choice, because I know Haiku takes away the letters, right? And this was obviously, I copied and pasted from a piece of paper file, and other than not the upload file that I have you guys have, okay? All right, what else? Guys got to give me problems. Number 3. Okay. All right, so we have to evaluate the limit if it exists. They didn't give me any function, though, did they? Okay. It didn't approach. Did anything? Did yours always have one where it approached anything? That's a bad problem, isn't it? All right, let's say I'm going to guess that I missed typing something, so I'm going to say the limit exists as x approaches 9. Why did I choose 9?
Because you're going to have to make this try to figure it out.
Yeah, because 9 would make the denominator 0, right? So this is one where we have to rationalize the numerator, so we take and we multiply top and bottom by the conjugate of the numerator. So the limit as x approaches 9. All right, so let's see what happens on the top here. So the radical times itself is what? Yeah, at the stuff underneath. Okay, minus 5. This is a really bad problem because I don't think it's going to work out here. Let's see. Oh, yeah, it does. What's negative 2 times 2? Negative 4. And I only have to do F and L, right? Because they were conjugates. And then I've got an x minus 9, and I don't try to distribute or foil this mess here. What's this going to turn out to be? X minus 9. So what happens with your x minus 9s? They cancel. That's how I knew what the typo was, right? Because it was pretty obvious. We've seen this type of problem before. So those go away. I now could take the 9 and plop it in there. Oh, wow. It actually turns out nice. We take the 9 and put it in there. What's 9 minus 5?
4.
4. Square root of 4 is? 2 plus 2 is? 1/4. So it looks like it's like the first one, eh? Okay. Is that one good? All right. All right, what else? Quiet. Normally on review days, we're just all full of what we want to do. 8? Okay, you guys got to be loud. Believe it or not, I do sometimes, sometimes am not able to hear you, okay? So, don't be quiet and shy about it, all right? We got to get it taken care of. All right, before I find this limit, I cannot just plug in a 2, right? I have to factor first. The denominator is easy, x plus 2, x minus 2. The numerator, on the other hand, is a difference of cubes, Okay, so remember we had a pattern. Which sign should it start with? Negative and then plus plus. All right, cubed root of x cubed is? Cubed root of 8 is? 2. And then we square the first one, square the last one, and then multiply them together, ignoring the middle sign. Okay? What cancels? X minus 2. So I've really got the limit as x approaches 2 of x squared plus 2x plus 4 over x plus 2. I'm going to take that and I'm going to plug it in. Okay, so when I plug in a 2, what's 2 squared? 2 times 2? And then it's a 4 on the end, right? And then all over what? 2 plus 2, which is 4. So I've got 12 over 4, which is 3. Yes?
How'd you get 2 and 4?
How did I get 2 and 4 where? Here?
Yes.
Oh, this factoring that I did? So it's called different, or it's the sum and difference of cubes factoring. Do you remember the sign pattern?
Yes.
Okay. So to the pattern after you get this, you take the cubed roots, you square this for the first one, you square this for the last one, and then you multiply these two together for the middle, but ignore your sign.
It's valid. I'm talking about how did you get 2 and 4?
2 and 4.
Like, it's
Oh no! I want to understand where you're lost. What 2 and 4? This 2 and this 4?
and that 2, beginning 2.
This 2? Okay, so what's the cubed root of 8?
2.
2. That's where I got that 2 from. Okay, and then from there I square the first one, square the last one, and then I multiply these two together for the middle, but ignore the sign. Okay, makes sense now? All right, I don't want you to be frustrated with me. Okay.
I'm not frustrated.
Okay, it's okay. Don't let me give up on your question. If you still have a question, you got to let me know, because I don't want you to be lost. I want you to do well on the test. Okay. All right. What else? You guys tell me, what else do we need to talk about? 10? Okay. All right, so on this one, and this one you're going to see something similar if it's not this question. Okay, so I would probably put a star by this one and make sure we know how to do this one. This is the thing where I have to make sure that this and whatever's down here match, because I know that that limit goes to 1. So I need to artificially add in a 2. So the way we artificially add in a 2 is we multiply top and bottom by 2, because it's like multiplying by 1, right? So I'm going to rearrange that. Limit as x approaches 0 of 2 sine 2x. I'm going to switch where the 3 and the 2 are, and it's multiplication, so I can do that. So what does this limit here approach? 1. So what's my limit overall? 2/3. Yes. Why did I choose that? Because this and this have to match in order for that limit to work. Okay. So I knew I had to. I knew I was missing a 2. So that's how, and remember, you can't change it. So, but I can multiply by 1, which would be the 2 over the 2. Yeah. The 3 and the 2, because it's multiplication. I'm allowed to. It's commutative, right? I'm allowed to move where multiplication goes, right? Yeah. It's like as if it was one fraction, and I could just switch the order of it. Okay. Caesar, what's wrong?
Yeah, it's kind of the same thing.
Okay. Just commutative property. All right. Everybody good? All right, what else do you guys want to talk about? We've got about 15 more minutes here. 10, 15 minutes to ask questions, and then we're going to do our unit circle again.
I mean,
12?
yeah.
Okay. All right, so on this one here, it looks like I probably want to do some factoring first. So the limit as x approaches 0, because I can't put 0 and it would make my denominator 0, right? So I've got sine x over, what can I take out of the denominator? X, good. What's left behind? Good. I see something here. I'm going to rewrite it to make myself see it a little bit better. I could rewrite it as sine x over x times 1 over x plus 3. Do we understand what I did? I broke it up, right? I broke it into 2 separate fractions with multiplication. What does this limit here go to? 1. So now could I just plug in the 0 and not have to rewrite the step? 1 over 0 plus 3 is going to be 3, so 1/3.
So I have a question.
Yes.
Are you gonna like record yourself like over the weekend doing it, or are you just gonna record it?
I'm recording it right now.
And when are we done with all the problems?
We could do more on Tuesday. There might be an old one out there from last year too. I'll see if I can find it. If I'm going to get papers graded, I probably won't have time to record. Okay. So I'm sure that there is one from last year. And I'll look for it this afternoon and try to put it up there with you guys. Okay. All right. What else? 19. All right. So this one here, we've got to use the graph of the following for the next 5 questions. So the limit as x approaches 2. All right. So 2 overall would be this value right there, right? So what are we coming at? What y value are we coming at from the right and the left? 0. Okay. Easy, right? There should be some easy ones on there.
Are we gonna need a graphic calculator?
What happens is just like we did, I can't remember if we did on the summer work test, I think we did, where we had part of it on the calculator and part of it not. There's very few. The calculator problems are more the ones where you've got to find the limit numerically, where we did the boxes, remember we did the table? Those are the 2 calculator questions, okay? All right, what else? 16. Okay, 16, we can't just plug the 2 in, right? So we've got to figure out a way to change it. I'm going to try to multiply everything by the lowest common denominator. Okay, so what is the lowest common denominator up here? Not just x, but 2x. So this is some algebra. We may or may not have seen it in the homework, but I also have to do that on the bottom. Okay? Because again, it's like multiplying by 1. What I'm really doing is I'm taking this, I'm distributing that 2x over the top. Okay? So let me rewrite. Limit as x approaches 2. What cancels in this first one? X. So I'm left with 2. What cancels in this one? 2. So minus x. And then in the denominator, I get 2x times x minus 2. Oh, I see what happens. Do we see something that might cancel? What am I going to have to do to it to get that to cancel with the denominator? Flip it and take out a what? Negative. Can you handle me doing that all in one step? Okay, so I'm going to pull out a negative. Okay, and so that x is going to turn positive and the 2 is going to turn negative. Now does it cancel? Yes. So you got to look for stuff like that. And I probably somewhere on the test, I will probably put a backwards one like that. So watch for it. Okay? All right, so I'm plugging in a 2 now. So 2 times 2 is what? Negative 1/4. Second time we've gotten a 1/4 answer, huh? Okay, what else? Are there any others that we need to talk about? 24? Okay. All right. So we've got a right and a left-hand limit. They look like they're equal. It says that f of 3 is not defined. Which of the following statements are true? Okay. So it says that the limit overall equals -1. If the right and the left-hand limit are equal, does the overall equal that number? Yeah, so that's a true statement. Notice how I just wrote a true there? Okay? That's how I think of it. I try to figure out what's true and false, and then I go look at the answer choices on these. F is continuous everywhere except at x equals -3. On this one here, is that true or false? Why is it false? Yeah, it's not defined there. Okay, so I don't know. On here, I don't think I'm able to tell, am I? No, was the answer choice, was it A? Is that the right answer on the, because it should have told you, right? Yeah, because it's either got to be A or D, because I know that that one's definitely false. I'm pretty sure it's A. Okay. All right, what else? Is it D?
Yeah.
It's D? All right, so why it would be, the reason it would be D is because if they're both approaching, then there should be a hole, right? So whatever it is, -3 was where it was at, 1, 2, 3. So we've got, and it said it was -1 was the thing. So that means we've got a function over here and a function over here. If they're both approaching the same, there's not it can't be an asymptote, right? Because they would be going to infinity or negative infinity. So this one would have to be true. Okay, what else? Did I hear was 25 on there? Oh, there is no 25. Awesome. All right.
How many questions are you testing,
I don't know. Usually around 19, 20. So we've got, remember, these aren't the exact questions, right? You still have the hints too. Okay, so basically I give you a pool of like, 40 some questions and I narrow it down from there. Okay, what else did you want me to do?
Number
7?
seven.
Okay. Okay. Oops, that's not the 7 we're looking at. That's going to be Monday, huh? Tuesday. I know. Apparently I want to be here on Monday for some reason. I don't know why. I'm not going to be. All right, what's this reduced to? 1. So what does the limit have to be? 1. We probably want that question on the test, right?
Please have it.
We'll see.
We'll see if we trip up on it.
See if we trip up on it. All right. Are there any others that you want me to go over right now? 11? Okay. All right, so the graph it looks like it's talking about vertical and horizontal and removable discontinuities and those things. So I'm going to go ahead and I'm going to factor that thing because I know that's how I figured that out. So what does the numerator factor into? Good. And then the denominator factors, what do I take out? 3, and I'm left with? So that cancels. So when it cancels, what is it? A whole at where? X equals 3. And a whole is what kind of discontinuity? Removable. So it's answer choice C. What if it was left behind? What do we call that? Not what kind of asymptote? Vertical. We will eventually get to the horizontal. We actually talked about the horizontal in math analysis last year, but we have another way to talk about it here in calc. Okay, but we haven't gotten there yet. So we don't know this yet, so it's not the answer. Okay? We will know it eventually. All right, what else? Are there any others that you guys want to talk about today? Which one? I don't know. Did we do 16 yet? Yeah, we did 16. Which one? Any others? 9. Okay. Okay. Again, so this came up a second time, right? If this is a 5x here, what does it have to be down here? So what do I need to multiply top and bottom by? 5 over 5. So I've got sine of 5x over x. I'm going to rewrite it, right? Do I have to do that? No. But I'm going to make it official so we can actually see it. So what does that limit go to? 1. So what's my limit overall? No. 5. All right. What else do we need to talk about? 23. Okay, so, and again, you should be able to do these pictures. I have a feeling there's a bunch of these similar pictures on the test, so make sure you understand all this. Find the function f has a jump discontinuity at, okay, so where are the two jump discontinuities? What x values? 0 and 1. Okay, so which one would we pick? B, right? Because the 0 isn't there, right? Okay. Are there others that you want me to talk about right now? 14? I don't think so. But let's look. We haven't? Okay. There's 14. So let's see. We've got two functions, sort of. It's saying it's not 1 here. When it's not 1, it's equal to 4. Which of the following statements are true? The limit as x approaches 1 exists. F of 1 exists. So we know f of 1 exists, right? It's equal to 4. Only way we know continuity is if we test the right and the left-hand limit. Okay, so let's talk about that. Limit as x approaches 1 from the left. Actually, look at this. Couldn't I factor that?
Yeah.
So it would be x plus 1, x minus 1 over x minus 1, right?
Yeah.
So we know that the limit exists, doesn't it?
Yeah.
That's true. As x approaches 1, what is the limit, not right or left? Limit as x approaches 1 of that is going to be what? 2. So is it continuous? this number and this number would have to be the same, and it's not. So it's false. So it's just got to be 1 and 2. So it should be C. Okay. All right. What else? Is there any others you guys want to talk about? 22? Okay. We'll do, you want to do 15 too? Okay. We'll do it next. All right. Which of the following intervals is F continuous? All right. So let's see. I see it says between -1 and 0. Is it continuous there? But is it closed at 0? No. So that one's gone. Between 0 and 1, is it open on both of those? No. Okay. Between 1 and 2, is it open on both of those?
No.
It is, but it shouldn't be, right? I meant to say closed, huh? All right. Between 2 and 3, what is it there? It should be open and closed. So does that one work?
No.
Is the answer really E, none of these on the thing? Yeah, nice. That was a good problem. All right. I don't like that one. So what was the other one? 15? Is that right? You want me to do 15? Okay. So we've got the function. If f is continuous at x equals 0, then k equals. So it's very similar to what we did before. Okay, what's wrong, Caesar?
On 20, it was 22, right? We just went over it.
You're one of those. I can't remember.
Well, I clicked none of these and it says it's wrong.
Oh, what does it say the right answer is?
0.
Zero.
X is between 0 and 1.
0 and 1. That doesn't seem right because of the way the inequalities were, right? Maybe I have the wrong answer. Okay. Do you see why I don't agree with it?
Yeah.
Okay. I would say none of these with what they have. If there was a dot filled in somewhere or there was an inequality typed incorrectly, that's possible. Okay, I maybe typed the inequality correctly. Okay? Or incorrectly. All right, looking at this one, if we got to be continuous, that means both branches have to be equal to each other. Okay? So they're wanting me to plug in what number for the x? 0. So I'm going to put 0 in, on the top there. Can I do that? No, what should I do to it first? Factor out an x. So I've got x minus 1 over 2x. What happens with the x's? Now can I plug a 0 into that? So 0 minus 1 over 2, and we're setting that equal to k. So what do we end up with? Once you get the concept of the process, you have to do the arithmetic part and the algebra part. It's pretty easy on these. Okay? All right, is there one more we want to see? Quick one? No? What? You want to go over the unit circle again?
How about we do the simplification ones?
Just the simplifying ones? Okay, 13 really quick, and then we'll talk unit circle really fast, because we've also got to talk about fundraising today. Okay? All right, which statement is true about the curve? We need to know vertical or horizontal, which means I got to factor this thing, right? So the numerator, I'm going to take out a 2. What am I left behind with? Plus 2. Okay, the denominator, I'm going to take out a -1 to begin with, which is going to make this positive, negative, negative, which if I went and did my magic x would be -8 and -7, so -8 and 1, right?
Can we just cherish that moment real quick?
Can we what?
Because you did the magic X on him. I just want to cherish it.
You want to cherish the moment, but you're not going to like what I do next, because Rondo does it different than I do from on this step here. Because I don't, whatchamacallit. Let's say -2 and 1, is that right? 4x plus 1, x minus 2. So I would say that nothing cancels, right? Yes, did I do it wrong?
Where'd you get -8?
-8 from two numbers that multiply to -8 and add to -7. Oh, the first -8 I multiplied 4 and -2. Okay, it's okay. All right, so I'm setting both of those equal to 0, right? Because they're both vertical asymptotes. Because nothing canceled. So 4x equals -1, x equals -1/4 is a vertical asymptote. That looks like the right answer, right? 2 is also a vertical asymptote. Okay? All right, let's stop there. What did you want me to do for the unit circle? I'm not going to do the whole unit circle again. You want the simplifying part? Okay, so if we had 1 over 2 and square root of 3 over 2, what does that equal to? Square root of 3 over 3. Okay, and then if I have 2 over square root of 2, what does that equal to? It ends up being square root of 2, right? Because I multiplied top and bottom by radical 2. Okay, the radical 2's end up canceling, or the 2's end up canceling. What if we had, what else is there? Oh, 2 over square root of 3. 2 square root of 3 over 3. Okay, what if we had, what's the other one? I got that one already. 2 square root of 2 over 2 square root of 2 is what? 1. I think that's all of them, isn't it, for the simplifying ones? All right. So here's what I'm doing. I'll pass out the unit circle. Okay. Get on your Chromebook, close all the tabs except for the unit circle test. I believe it's test D today. Is that right? It's set for 15 minutes. Okay. So as soon as you finish filling out your unit circle, hit the button.